All right, so this is Pre-Calculus 30. This is from the Chapter 6 review. And of course, in Chapter 6, we're learning how to prove identities, trigonometric identities. So the question is, we're going to do 13b here right now. It says that prove each identity holds true for all permissible values of x. And of course, when you see that kind of wording, what you're trying to do is you're trying to transform one side of the proposed equation so that it looks like the other side. We're always going to choose the most complicated side if we can. And so that's going to be this side here. So let's focus on this side over here. And cosecant of 2x, we know that cosecant is actually 1 over sine 2x, okay? And cotan, now we could write this as 1 over tan 2x. We could do that. If you want to look over here, see tan 2x, we do have an expression down here at the bottom right. We do have an expression for tan of 2x. It's going to be this over there. We could also write this, though, as cos of 2x over sine of 2x. So watch, and that's going to be actually the better way to go, I think. So cotan, tan is sine over cos. Cotan is cos over sine. So this turns into cos of 2x over sine of 2x. And what you want to see here is that I have a common denominator, and so that's going to help me to perform the indicated operation, which is always something that we want to try and do. You want to try and get two terms combined into one term if you can. So let's do that. I can just simply combine the tops now. 1 minus cos of 2x. 1 minus cos 2x all over sine 2x. Okay. We're not real close to tan x yet, so we still have to take a look at our identities and see what we can do. So I see cos of 2x and I see sine of 2x. So cos of 2x, again, we have three different choices down here, right? And we have sine of 2x kind of right here. So sine of 2x looks like it's going to be 2 sine a cos a. Cos of 2x could be cos squared minus sine squared. It could be 2 cos squared minus 1. Oh, I like that one. Or 1 minus 2 sine squared. Oh, I like that a lot too. Okay, so look at this here. When you have a 1 in there, you see how I have a 1 up here? Okay, if I were to substitute this 1 minus something, if I could do 1 minus 1, that would get rid of that 1 altogether, wouldn't it? So I like that a lot. And plus, we have a sine x, and we're going to have a sine x on the bottom. So all that to say, what I want to do is I want to turn this cos of 2x into, I think this one right here. That's where I want to go, okay? I'm going to rewrite that. So I'm going to have 1, leave that one there, minus what? 1 minus 2 sine squared of x. Okay, that's what the top now equals. And the bottom, sine of 2x, let's go ahead and rewrite that as 2 sine x cos x. 2 sine x times cos x. Okay, so what we see here, again, is the 1 minus 1. Those are going to be gone, right? And I have a negative, or a minus negative 2 sine squared x. Okay, well, that becomes positive. So I have 2 sine, and I'm going to separate it like this. Okay, sine squared is sine x times sine x, right? So this is what we have on the top here now. And on the bottom, I have 2 sine x times cos x. Awesome. What that means is I can divide out the 2's and I can divide out the sines. And what am I left with? Sine over cos is tan. So that equals tan x. So this side I have just proven through manipulation and through rewriting identities that I can transform this side into tan x, which is the same as our original side.